So what we saw in the last video is that these set operations kind of have this connection to logic. And so let's explore that a little bit more here. So let's say I have two sets, A and B. They're sets contained in a universal set, U. And then I'm going to make this connection between my set relation and my logical operator. And then I want to focus on the definition after that. So let's start with our first set operation or set relation. That was subset, which the way we denoted a subset was like that. And what it corresponds to in terms of logic is it corresponds to an if-then statement, which remember is a conditional statement. It's an arrow. So here, A is contained in B if and only if, and I can write the condition for a subset in terms of a conditional statement. For all x in my universal set, if x is in A, then x is in B. So subsets connect to this idea of the conditional statement. Then we had intersections. The intersection, which we use that symbol for, connect to the logical operator and. So you can write A intersect B as all the elements of U where x is in A and x is in B. So after intersection, we had union, and the symbol for that is a U. This connects to an OR statement. So A union B would be x is in U such that x is in A or x is in B. Okay, and then we had the complement, which you either write as A bar or A with a superscript C. These correspond to nots or negations in our logic setting. So the complement here would be all the elements of U where x is not in A. If I have equality, so two sets are equal, this corresponds to an if and only if statement, which is our biconditional statement. So two sets are equal. The definition of that is for every element x in U, x is in A if and only if x is in B. And remember, our biconditional statements are made up of two conditional statements. And finally, the last one is set difference. Which is either denoted A minus B or A slash B. And this corresponds to an and statement, but with a not statement. So if I write A minus B down, the definition of that set, it's all the elements in U where X is in A and X is not in B. So those are the connections between our set operations or our set relations and logical operators.